Thanks everyone for inviting me here. Sorry I had the wrong time in my calendar and ended up turning up a little bit late. So I'm going to talk a bit about the challenges that we received from the discussion. So my slides are going to be purely addressing the challenges and issues there. So I don't have sort of product slides in here, but there are a whole bunch of, let's start at the top here. So leadership principle number one for Amazon is customer obsession. I regard this as an opportunity to have a discussion with a group of customers that have interesting problems. My job at AWS is cloud architecture strategy. What do we do next? We're trying to find the problems that we need to address as we go forward. So this is a good opportunity to do that. I looked through all the adoption barriers. I'll go through them in the next few slides. Overall, I think AWS products and programs address many of these, or we're trying to address many of them. They're all reasonably familiar problems that we've heard from lots of our customers already. So I'll go through and just try to figure out where we think we have gaps. But generally, if you think about across all the different CSPs and you think about a particular application, you can kind of say, there's a minimum set of functionality needed to solve a particular problem, and you kind of have to be this tall to ride this ride for some of these things, right? If you don't have all the right certifications for a market, it doesn't matter what your product is. You have to have got all of the compliance certifications for it. So what I think is interesting is across all of the different types of applications that everyone is building, there are different profiles for what different classes of application look like, and some profiles are relatively easy, and you can maybe like standing up a marketing website, you can do that in just about any kind of platform. Some of them might be replacing a back-end mainframe that's moving billions of dollars a day. Those require really advanced architecture with a whole lot of work, which is going to be hard to do that's going to be down to a small number of suppliers that are actually going to have everything they need to do that. So that's what I mean by you have to be this tall to ride this ride. Define what are the different rides and then figure out what those profiles are, and then we can work out, basically get everybody up to different levels. So there are a bunch of asks, and what I want to do here is clarify which ones are already being met by AWS, and we can start discussions with various teams across AWS for places where we need follow-up. So the first barrier that was mentioned in the spreadsheet we had as a briefing was education training and architectural training. And there's several ways of approaching this. One clear way of avoiding the need to figure out a cloud architecture is to just go with your VMware architecture. And we have a partnership with VMware that we launched last year, and it's just starting to roll out, where you just transparently continue to do whatever you did on VMware with all your existing tooling. It's just that instead of buying another rack of servers and installing them in your data center, you're actually using an AWS account underneath. So it's totally transparently VMware, using VMware accounts, your VMware licenses. It's sold through VMware. We're supporting those sales and helping out, but the entire process of rolling this out to the customer base is being driven by VMware. So this is as transparent as you can get, and this really came from customers saying, I just have to get this data center closed. and I don't have time to move stuff and port stuff and install new stuff. I already have my licenses. I just want to shut a data center and move a bunch of stuff over, and we can do the greenfield apps here, but I have all this other stuff that I've already moved to VMware, and I don't want to have to do another port of it. So that's where that came from. The hardware that's running under this is interesting. It's the first time that AWS has done bare metal, and the VMware hypervisor is running on a bare metal AWS instance. There is no hypervisor stacking here. So you get the same performance you would get if you'd bought that box from real physical hardware in a data center. All of the networking and security is in a daughter card that is completely outside the hypervisor and not running on the core processor. So that's one way of reducing some of the barriers for hybrid cloud, and I really regard VMware as our partner for hybrid cloud, where this is kind of the end state for where you want to be hybrid. This is a major partnership between the two companies. We've also got this thing called the Well-Architected Guide. This is a really useful basis. We've been collecting this and enhancing it. There's a guy in the UK that's been maintaining, that started this, but we've been sort of piling on, working on it. So if you go and look for the Well-Architected Guide, we have kind of set of standards for things where, you really have to have your security stuff sorted out and your key management sorted out and your availability model figured out. There's just simple things that we think are basic, well-architected applications. We've been doing lots of training. So my other part of my job is I've been keynoting summits. You probably saw Werner Vogel's keynoting a summit in San Francisco last week. I keynoted 2 summits last week, but they were in Kuala Lumpur and Seoul and Singapore the week before that. And people kept saying, "You're going to be at the summit." Yeah, but not that one. So I'm doing about 10 summit keynotes over this summer. I've got Stockholm next month. I'm going to be keynoting in Chicago in July, and I'll actually be doing one of the big ones in New York in August. Yeah. So I know a bunch of you are probably from the East Coast, and that's going to be my main time in New York. So the summits are free. This is really interesting. It's like, they have turned into pretty much the biggest conference in Singapore is the AWS Summit. The biggest conference in Kuala Lumpur is the AWS Summit. We've run out of space in the conference facilities, and we're maxing out, the 5 things. Well, why are they free? Well, they're free because if you look at Kuala Lumpur, 2/3 of the people coming there were either completely new to AWS and had no relationship to us at all, or they were people who were just starting to tinker. I mean, that's relatively a new market. But by making these things free, we get new people in, and we start the education process, right? We have to figure out how to scale this for next year, but we're really maxing out this year. So these events are usually between 3,000 to 10,000 people come in each time in a city, and we bootstrap a lot of people into the cloud. Obviously, the certified training programs, a lot of work we've been doing that. And we have a really strong system integrator and education partner program with people like, used to be CXC, but they're now DXC, Accenture, many of the large accounts that you see as doing big transitions to the cloud. If you scratch and look under the hood, you find there's a bunch of Accenture people there, a bunch of DXC people there, and there are other partners around the world that we're working with. We also have recently started with a managed services program. So this is basically AWS has people that will actually manage everything for you. Like, this is just the same as any other managed service provider contract that you might have for other capabilities, but the actual provider on it is AWS fronting it, and then in various parts of the world with the partners behind that. But it's an offering that we've just started coming up with. And then we have the Migration Assistance Program, which is it's a combination of things, but basically the way to think about it is when you're making a rapid migration, you have a lot of extra cost up front because you're running stuff side by side, and you have to make some additional investments. Part of the map is that we actually offset the cost. We give you a very large discount up front to basically cover the fact that you're bootstrapping your new environment. And what we get in return is you commit to move a certain number of applications in a certain time frame. So it's kind of a forced march that if you commit that you really are going to move this much capacity in this time frame, then we come up with a model which gives you a discounted cost up front and professional services support, really hands-on professional service support to make this successful. So we rolled this out last year. We did about 20 of these map things, and we're doing probably a few hundred of them this year. So this is turning into a major program. And this is quite often, again, this comes back to customers coming to us and saying, our data center's coming to end of life. Rather than investing in a new data center, we want to just shut it down completely and move this all to AWS. So that's really what drove that. Another part of the ask was to have a generalized concept cloud curriculum. I'm happy to help facilitate what that might mean. We already have quite a lot of support through our educate team and our public sector team. So there's a fair amount of content there. We can certainly connect people into the right people at AWS to handle that particular ask. Well, I guess we get to questions later, so I'll just put this. I've got about 10 slides, so hopefully I'll finish in time. Let's talk about data migration and data jurisdiction. There's talk there about data mobility risk, and I think I want to be very clear that customers own and move their own data. If you put data in one country, it stays in that country, and AWS will never move it to any other country. So it's actually no different to your on-premise. There's no additional risk from data movement point of view compared to your data center. If some data's in a data center, you have to move it somewhere else. So we also have this, it's quite a few of our products have this bring your own key thing, where we basically we'll only hold keys in memory for the time taken to actually encrypt or decrypt or query some data, but we wipe that from memory and we don't persist the keys. So that means if somebody says, if somebody gets hold of some raw data via whatever mechanism, it's just raw scrambled bits. If they want access to that data, let's say somebody subpoenas us and says, we want to see this customer's data, we can say, well, we don't have the data. You have to talk to the customer to get the key. So this part of the sort of architecture lets you really manage what your exposure, and this is actually good enough for many people to let data go outside jurisdiction, because really, as long as the keys aren't persisted outside the jurisdiction, then they're fine. So number of approaches there. And then there's this neat thing that we actually can query the encrypted data in space. If you have a whole pile of compressed encrypted data in S3, you can just run queries, SQL queries against that now without doing anything else. You don't have to read it, don't have to decrypt it. You just, every query, you pass in the key that's needed, and for the duration of that query, Athena will just pull up the data and give you an answer. And quite often these responses come back in a few seconds, even for really, really large queries. So Athena's been out for 6 months or a year now, a little while. Redshift is our data warehousing capability, and Athena is more for querying the S3 data. Redshift Spectrum was announced last week at the summit, and this is a really staggering product. We actually tested it on an exabyte query. We've only gone up to an exabyte. We had to create an exabyte of data and run a query against it. It's the data that is sitting in your archive that hasn't been loaded into your data warehouse. We can actually you can run a query across that, and it does a parallel load. You don't have to allocate individual machines. Again, you can query the encrypted data. You provide the key just for the duration of the query. You don't have to have the data sitting in memory or on disk in some decrypted form. So there's a bunch of architectural things here for really giving you tooling for getting applications and particularly data science applications to work right. Another point here, the migration tools that we build are all bidirectional. We're not trying to roach motel you. You can use them to take data, put data somewhere else, bring data in, put data back. That's kind of basic principle. And then there was this question, data portability is expensive to move stuff. I want to put some real numbers on it. Okay, 100 terabytes is a fairly large amount of data, I think. If you just store that in S3, it's going to cost you $45 a month to just leave it there, which isn't a huge amount of money nowadays, right? I mean, it used to be 100 terabytes a day would cost you quite a lot. So it's $45 a month. That's triple redundant, 11.9's durability, stored on 3 zones. So it's not just the cost of a disk, right? It's the cost basically of 3 disks with some resilience on it. If you want to move that to a different region in AWS, let's say you have data in California, you want to make another copy in another region, it will cost you $10 to move that 100 terabytes to a different region. Using that data within region is free. We don't charge for consumption of data within region, but if you want to move it to another region, that's about $10. If you want to export it outside AWS to, say, another cloud provider for archive backup, that will cost you $70. So if you think about the cost to export is about between 1 and 2 months worth of just keeping the data here in one place, I think it's not an unreasonable amount to think about, right? If I just left it here for 2 months, that would cost more than moving it. So my cost to move is between 1 and 2 months worth of just leaving it resident if I want to move data around. So anyway, I think it's you could think maybe moving data is expensive, but let's just sort of pull it back to some real numbers for actual things. Now, one of the problems with moving large amounts of data is you run out of bandwidth in your data center because you only have enough capacity, network capacity provisioned for your actual workload. And if you throw on an additional, hey, let's move 100 terabytes this month, you'll tend to blow up your network and have to provision more capacity. If you don't want to do that, we have these snowball disk transfers. So it's an encrypted, ruggedized box of disks. You have 80 terabyte, we do an 80 terabyte and a 50 terabyte version of it. $250, you get it for 10 days, you stick it in your data center, throw your data into it, then it ships itself back to AWS and you offload the data from it. Both ways. So if you want to take data from AWS and move it to some other place, you can just get these things and ship them any way you like, right? So that is really good, and we have a truck full of these with a few petabytes in it. If you have your digital globe and you're trying to, mapping the entire surface of the Earth, and they do have several exabytes of data that they're trying to move to S3. But anyway, they have the truckload version. I don't know what that costs, but you have to be able to feed it at least a terabit to justify having the truck turn up. So that's the minimum requirement. And the other point really is data center to cloud typically is where you run into bandwidth problems. If you've got something in a cloud region from any vendor, and you're going to another cloud region from any vendor, there is so much bandwidth between the regions that you don't really have the networking problem. Yeah, it's easy to get hundreds of gigabits between any two regions, probably from any two suppliers of just spare capacity. You can just use it, pay for it after the next month. But you don't have to go and provision extra capacity like you'd have to in the data center. So data portability and data gravity is substantially less once you are in the data center. Once you are out of the data center into at least a cloud, it's much easier to move things around. Another thing we were talking about was the financial model, and there was a question, could we standardize the TCO model? Well, there is a AWS standard model. Happy to work with some people on that. We have a cloud economics team. We engage those whenever a customer wants a bespoke TCO model. And I think the challenge here is that every customer we talk to wants a different TCO model. So the problem isn't that the CSPs all have different models. It's that every customer wants a different model. And we haven't really got to a point where everyone agrees what is the right model. But certainly happy to connect people to the cloud economics team to have that kind of discussion. And obviously they're doing this for lots of people all over the place. And there's a group, an expert team there. Connectivity and availability. We have a whole bunch of options that have been around for a long time. I'm not really sure what's missing here, but happy to have a discussion about what the features might need to be. But I think that we still have some philosophical differences between the CSPs that are really hard to paper over. In particular, we have a CloudFront, which is our CDN. We now have ability to put code at the edge of the CDN and have that fully integrated into our cloud architecture. So you can have a Lambda function running at the edge that's a few milliseconds from the customer. That's something that you can't just paper over that with an API. The 16 regions that we currently have, there's 3 more announced and coming. There's no shared network address spaces. Right, this is something you see from some cloud providers. They have a global address space. That provides a failure mode because if you can screw up an address space, you lost all your regions. So we truly have extremely isolated regions, and we've been pretty good about not having any incidents sort of spread from one region to another. And that's something to think about is as soon as you have an address space that spans regions, you're coupling those regions in a way that's exposing you to a certain class of problems. It makes it easier to deploy applications, which is why some people do it, but we'd rather do that within a region. So we have a shared address space across typically 3 zones in a region, 2 or 3 zones. The smaller regions have a couple of zones. And we think that our zones are at least tens of miles apart. That's for synchronous replication, and we think that there's really a philosophical difference here between Azure, where Azure's regions fall somewhere between zones and regions for AWS. The model does not match, right? We do synchronous replication across zones, we do asynchronous replication across regions, and that's the basic approach we have. Accounts, identity, and policy. we've recently rolled out this organizations thing, which lets you define in really sophisticated terms what your organization looks like. We have people running their entire AWS footprint on a single account. We have people doing it on tens of thousands of accounts running in a single organization, and everything in between. The sweet spot is probably to stay away from the 10,000 end of things. That turns out that's pretty hard to deal with. But certainly, we have lots of options for single multi-tenant models, bringing things in, even for some of our really large accounts. We have ways of doing that. So again, I'm not quite sure whether friction or adoption here is here, and maybe it's just differences across CSPs, but we think we have a good solution for that. Again, IAM roles, service catalog, we have lots of ways to implement policy that says these are the services this role is allowed to use, these are the things that you can do with it, and we can track all of that stuff. We have a tamper-proof audit log in CloudTrail, and that's for all of your, when the auditor turns up, they can come and do queries against a tamper-proof log that says every entity, when it was created, every config change, basically your entire infrastructure is knowable. I did a blog post on this recently. I called it the epistemology of IT. Epistemology is the study of what is knowable. If you look at studies of religion, they talk about epistemology, but this is what is knowable about your IT infrastructure. In the cloud, everything is knowable because you can get a full tamper-proof log of every API call and who made it, and every state change for all of your infrastructure, all of your services, every security group change, all of those things are knowable. And that's something that's very hard to get in a data center environment. Your CMDB is usually not quite in sync with everything else. We have, if you just go to Amazon/compliance, we have lots and lots of compliance certifications. Happy to hear if they think there are any missing that we need. We're always working on more of those, and we're going into more markets and more countries as we get into more of them. Just a little bit more, I think it's pretty much the last slide. So visibility is an adoption barrier. CloudTrail, as I mentioned, gives you really good tracking of the infrastructure state changes. And then we have VPC traffic flow logs, which you can pull out and feed to your favorite packet analyzing thing, but see what's going on. So that's flow level tracing. And then X-Ray has just come out. We just went GA on that last week. End-to-end APM. Which reaches into the services, which is something a third-party APM cannot do. Like, we will actually persist and store a transaction header ID into SQS or into Kinesis or into DynamoDB, so that when you do the read, you get that you can trace all the way through the services. And as we go forward, we'll be monitoring how much what the utilization of DynamoDB was for a request. That's kind of where we want to get to. This product's rolling out slowly because they built the core product, X-Ray. Then they had to go to every other service team and say, please implement X-Ray on those services. Lambda is only just in preview right now. But think of this as providing traceability for your application, transaction, effectively provenance across everything that we have. Okay, so just a couple more slides. The APIs just aren't really that portable across CSPs because they expose, you can only paper over the really simple, easy stuff. And I think it's harder to do as you start to get to the more realistic things that we're actually building. If you're building a serious application at scale, you're ending up having to pick a cloud provider and just go with it. But there's some mitigations here. Web services support secure remote access. This is not the same as the lock-in we had to APIs and services inside the data center. It's secure and it's remote. That means you can take your application and move some of it to another region or another CSP and leave some of the dependencies there. Right? It's perfect. You could use SQS, a queuing service, from any application on any cloud provider anywhere in the world. It's an HTTP access, it's secured, you can do that. You can use DynamoDB to support an application on Azure if you want to. It doesn't matter. Now, you've got network latency, but if there are places where the buildings are close enough together that latency is not going to be an issue. So that's one thing. Modern application techniques, continuous delivery. We're building rapidly evolving applications with time to value and updates measured in tens a day. Many, many updates a week. We're not building things where you deliver it and it freezes for 9 months and you can't change it. The freezing an app by delivering a project and handing it over to operations is what causes the lock-in. That's when you're turning the key in the lock, right? If you never actually do the handover and you're continuously evolving it, you have dependencies, but you're not locked in because you can keep refactoring those dependencies. And the other thing is the pace of development. We're now getting entire applications being built in a week or two. And if you want to go, well, I could just rewrite it again in a week or two. The pace of development, particularly with serverless, is staggeringly fast. Things that would normally take months are taking weeks. So that it just reduces the whole ROI calculation for whether you should rewrite something versus whether you should port it. Okay, final thoughts. We see hybrid cloud as a journey, not a destination for most customers. But the Netflix story was it took between 5 and 7 years to completely shut down that last data center. It's a bit faster now, but it's still roughly probably a 4 or 5 year long project to actually take everything and go completely all in on a cloud architecture. So there's a lot of work to be done to make that journey easier. So that's why we're invested so much in hybrid. So VMware really is our preferred partner for if you really want to stick with your data center and build something that is going to span data center and cloud. And we've been trying to fix this for many years, just happy to discuss what more is needed. All right, that was that. Hopefully it wasn't too long. Maybe a few more questions.
A few minutes, Adrian.
Okay.
Okay, we got mics over here. Just raise hands. I'll kick us off. I think one fundamental here is that there are a set of needs communicated by ONUG to the providers, and they are hybrid oriented. And each provider has a view of its scope of what it's trying to address. And what I hear you saying with AWS is that the scope is, first and foremost, movement out of data center into AWS, and second, with VMware as the partner for hybrid.
For data center oriented applications, yeah. If you really want to run something on data center and on cloud,
yep.
Yeah, and then
you really need a third provider to address a hybrid infrastructure using 2 different platforms.
Well, most people already have VMware, so that we were just making it easier for them to solve for that problem. So that's really the approach there. And then the rest of it is just, we're just listening to what our customers are telling us to do and building things, right? So we've just been turning the crank on that for almost 10 years now. And I'm sort of interested to know where where people think there is friction and things that are hard to do, and we'll go and turn the crank and build some more things. So that's kind of the attitude, right? Okay. And everything on these slides is stuff that's been built because enough customers said, yeah, we all have that problem. Let's go build a solution for it.
This is actually a role reversal for Adrian and I, because I used to be taking the requirements while I was at AWS from him at Netflix and acting on them. So a little humor in this for myself.
When are you going to deliver those solid state disks again?
Yes. Yeah. So your first question over here.
Yeah, hi, Adrian. Very good presentation. Thank you. Can you talk a little bit about APIs in general? I think I saw the mitigation and what you were talking about, but how do you see the world of API evolving? I mean, you see it consolidating into 2, 3 API sets across the globe, or?
So there's 2 things. One is you can't take away an API once you've published it. We've been very good at not shutting down things. That you can take code that was deployed in 2007 or 8, and I think it probably will still work on AWS today. That means our API it's got a lot of history in it. There is a lot of junk and things that we'd really like to shut down, but we can't because it would break something. So that legacy is one issue. And then going forward, the new APIs we're adding are usually really detailed features. There's sort of IPv6 support on everything now. So then we had to add stuff to the APIs for dealing with that, right? That touches almost everything, right? Because now you've got a new field and the network, you've got options to decide what you're doing. Then the things we're adding now are typically more higher level stuff. So the new services that came out recently, more in data science things, so APIs for doing that, for machine learning APIs. things like we have a call center application we just came out with, so you now could get a call center as a service. You know, that somebody could try and standardize the API around that, and if that makes sense, right? So we're adding more and more high-level features. So as over time, the common stuff just becomes commoditized and becomes very basic, and then we're adding more and more high-level things. So I think that I just see there's just a lot of APIs. There's going to be more, and we're not going to take stuff away. And then you've got some basic assumptions that are built into the API, like the model having zones and regions. And then the way the networking is laid out, that is basic thing. It's very hard to paper over that. I mean, you could have an API say, give me an instance. That level is easy, but if you're trying to deploy a really sophisticated distributed application, it's actually, I don't think you can really paper over what it takes to do that. You have to kind of rethink the way you're going to be laying something out if you're laying out your networking architecture differently. And a lot of the time I'm seeing the really large sophisticated customers getting the VPC network architecture right, and actually probably spending 2 or 3 attempts at getting it right is kind of what I'm seeing right now. That's really the main problem, that the APIs aren't really turning up to be a problem that we're hearing.
Okay, so we have time for one more.
Yeah,
Okay,
I
right here.
have the mic here.
Okay.
My question is about visibility, particularly what you see as Amazon's role in providing visibility solutions in the long run. And I'll go one more level specific. Up until now, companies like New Relic and AppDynamics have played a prominent role in providing APM-like solutions in the cloud, particularly. But you just came out with X-Ray, and you said that it's going to be even more comprehensive, essentially, because every service is going to be able to provide that tracing. So I guess my question is, do you see the partner ecosystem as an essential part of managing the multi-cloud hybrid IT? And if so, like how far are you going to go on your own to provide those tools, and what that does to those vendors?
Yeah, the way we're working with those vendors is that they've all been asking for ways to manage the entities which they can't reach inside, like the services. So X-Ray has a really good API for getting this data out and putting data in, and you can hook it into, all of these vendors are basically treating X-Ray as a provider interface, which will suck data in to their system. There's a number of ways you can leverage different sort of layers at which you can leverage it. It's a relatively simple service. It just manages stuff that's in the cloud. So if you've got any hybrid thing, you'd be wanting to use an AppDynamics, New Relic, Datadog, whatever, to manage across your infrastructure and all the different places it would be. And this is one of these sources. It's one of the providers into that. The model it's using is based on the Zipkin model, basically. They're all roughly similar. There's some standardization in that space around a thing called open tracing, which is an API which doesn't really specify an implementation, but it says how you instrument your code. So there's some work going on to standardize across vendors in the tracing thing, and we had a tracing workshop recently where we had the AWS X-Ray people and the open tracing people and the Google Stack Driver, whatever it is. There's all these different teams.
My question is on level about the fact that they charge by workload that they monitor. And so consumers with data source on the workload.
Let's get the microphone here. But yeah, so you're saying that they charge by the workload?
Well, the agent they put on a server to monitor that server.
Yeah, I mean,
So
everyone
if
has
you're
a
providing the
monetization
agent-
model. X-Ray there's a free tier for some level, and then beyond that, we charge on some consumption-based thing, how many metrics you generate, I think is the model we use. Some people charge per node. These products require quite a lot to run. So, there's different sales models around it, but the capability is there. I don't think there's the essential thing with X-Ray is that we're doing the things that no one else can do for us, and we're providing APIs and visibility into the core services that we're building out. And that we had to do that, and you can consume it at that level and plug it into whatever tooling you want. Or we're building a fairly basic tool at this point that will give you flows and requests and what's going on. And the other thing is the Lambda service, the serverless thing, that really was crying out for something more sophisticated and getting that integrated into it. So I expect all the other vendors to have something similar and be able to make sense of it.
Thanks, Adrian. I think we need to stop there. All right.
You got one more?
Keep going.
Time?
Okay.
Yeah.
One more?
We're out of time. Yeah.
One of the things that was raised yesterday was that roughly 65% of companies see moving a lot of their operations into the cloud in the next few years. But Nick had raised the point that there may be a shortage of skilled people, particularly in DevOps, to do this. There was actually a survey done by a Berkeley professor that showed that countries like China or Japan are graduating almost nobody with a degree that would be suitable to move into DevOps or data analytics, but countries like Poland or Romania had increased their number of grads up to like 30% or plus. So I was wondering, are you taking this into account as you're going around the world, or are you basically trying to patch over and get people up to speed as fast as possible?
I guess the quick answer is we're putting a lot into education. We hear that from many of our enterprise customers, certainly the large ones that are doing migrations, that getting experienced staff is hard. What we find though is that quite often the partners, you'll have someone like Accenture or DXP or a local smaller company come in, and they're the ones learning by doing multiple jobs. So they come in, and you're basically buying in, you're bootstrapping by having a team. We have our own ProServe team as well. So depending on how you want to, so once you get bootstrapped, it's not that hard. This stuff is NoSQL databases are much easier than SQL databases. The services are easy to play with. You don't have to, it doesn't take you months to try something out. It takes you hours. So I think the ability to learn in cloud is so much easier that the on-ramp for skills is just much shorter than it ever was in previous waves of IT. You just actually have to take the time to go do it. And most of the blockers to migration that I see are mostly internal company policy and organization problems or people problems. The technology is actually less of a problem. I mean, it is a problem, but it's not the main problem. I think we need to
All right. Thank you,
let the
Adrian.
speaker come up. So thank you.